Hello, good morning. Okay. Hello. Okay. Okay. Hello, Rana Shehbaz. Hello. Hello, Chand Khushi. Hello, Cheryl. Hello, Sania. Hello.
अस्सलाम वालेकुम मैम।
वालेकुम सलाम। कौन बोल रहा है?
मैम फरीद।
फरीद, यस। आप एटलीस्ट सलाम का जवाब दो ताकि आई नो दैट यू आर देयर एंड एवरीथिंग इज फाइन एंड सो दैट वी कैन स्टार्ट। ठीक है?
Yes ma'am, we can hear you.
Yes, that's great. So the rest of the people, Cheryl, Sania.
Good morning.
Good morning, beta. How are you?
I'm good. How are you?
I'm fine, thank you. And who else? Ali Zulkarnain.
Yes, ma'am. Good morning.
Good morning. How are you?
I'm fine. How about you?
I'm fine, thank you. Amelia.
Yes, ma'am. Good morning.
Good morning. Maiza. Chand Khushi.
Yes, ma'am. Good morning.
Good morning. Who else is here? Abu Bakr.
Yes, ma'am. Assalamu alaikum.
Walaikum salam. Rana Shehbaz.
Good morning, ma'am.
Good morning. Okay, so I think we have people who have joined.
Masi.
अच्छा सुनो मेरी बात, please mute your mics, okay? Who is this? Zoom user Muhammad Bilal. Okay, good.
Yes ma'am.
Right. Now, there are a number of things I would like to clarify before we start. So one of them is the fact that you know that a Zoom meeting ends after about 40 minutes, right? ठीक है?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
But then if you click the same link again, we can continue. ठीक है? So remember this.
Okay,
Okay
ma'am.
ma'am.
Okay, good.
Okay, ma'am.
And I've already given your homework on Moodle. So are you doing that? Please complete your homework, which has already been given to you on Moodle. Okay.
Okay, ma'am.
So this
Okay, ma'am.
this homework includes chapters 4, 5, and 6. Okay.
Okay, ma'am.
Right. Another thing is that, yes, I've also uploaded the lectures for the last classes during the last week. Okay, so you can access them by subscribing to YouTube. Is that clear? समझ आ रही है?
Yes, ma'am.
So you can find the lectures for the last classes. मतलब पहले तो मैंने आपको किया था ना कि I gave you links on Moodle. This time I've just directly uploaded them to YouTube. You can subscribe and you can access them. Is that clear?
Okay, ma'am.
ठीक है, but keep following Moodle, okay? Because most of the material will be uploaded on Moodle. Another thing I would like to draw your attention to is the fact that I've uploaded some tables and formulas in Moodle, okay? Like you remember the book that we are using in the beginning of this book, in the first few pages, you have some tables and formulas, right? That we have been using from time to time. Again, you don't need to be worried. You don't need to know all of them. You only have to look at the formula that's required for your syllabus or for your the work that you're doing. Okay, so similar tables and formulas are also given at the end pages of the book, and I've uploaded them on Moodle, so you can also access them and they will be helpful when you're practicing and solving and studying. Okay, right. Now let's go and start. After a short while, I will also be taking your attendance. And so I am going to share the book with you right now. Okay. So can you see the book that I've shared with you?
Yes, ma'am.
Good. Okay, so when you look at this, the topic we have to do today is work done by a general variable force. Okay? So I'm going to alternate between the book and between the whiteboard that I'm using. Okay? So from time to time, I will share the whiteboard to explain the concepts. And from time to time, I will share the book text that we are using. So what's the main thing in this case? You know, we talked about work done previously, right? So what was the work done we talked about previously? Previously, we talked about work, which is W, right? Is equal to F dot D. This was what we did last time. You remember?
Yes, ma'am.
So work
Yes,
is a scalar product of force and displacement. So this can be written as force multiplied by displacement multiplied by cosine of the angle between the two vectors of force and displacement. Now, in this case, the difference now is that the force is variable. Variable means it is changing with time. Previously, we assumed that the force remains constant with time. So this is the difference in today's topic. In today's topic, the force is changing. So we are considering the force in the x direction at this time, okay? And we are also considering that the magnitude of this force is changing. At the moment, we are not considering the direction to be changing. Okay, you know, a vector has both a magnitude and a direction. But in this case, we are talking about a force in which the magnitude is variable, it is changing, but the direction is not changing. The direction has been assumed to be along x-axis. Therefore, this force can be represented by F x. It's written like this. When you write x in the bracket, it means the force is a function of x. It means x is the position along the x-axis, and as this position changes, the value of f can change. Is that clear?
Yes, ma'am.
Good. So now we cannot use this simple equation that W is equal to Ft cos theta because, or phi. We have to change it a little bit in order to accommodate the fact that the magnitude of this force is changing. Sania Ahmed, please don't disturb the class, okay?
मैम वो गलती से हुआ है I
Please be
didn't do
careful.
it.
Okay, now when you look at this figure, I'm showing you a figure which is figure number 7.13. Okay, so this figure shows you a graph here. The A figure shows you a graph where you have the x-axis and you have the y-axis. Along the x-axis, we've marked the position of the work done. The work, when the work starts, the initial position is xi. When the work stops, the final position is xf. And similarly, along the y-axis, you have the variable force, which is fx. You can see that as the position is changing, the value of fx, which is the force, is also changing. And you get this graph. Is this clear?
Yes, ma'am.
Okay, now we cannot apply the standard formula that we had before, ft cos phi, because the value of f is now changing. In order to be able to calculate the work done, we have to divide this graph into parts, okay? Now you can see the next figure, which is B. You can see that this graph has been divided into number of parts, and each of these parts is a rectangle. And we assume that in this small interval, f is constant. F is constant here, f is constant here, f is constant in each of them, so that we can calculate the work done for each of them and then add them all together to find the total work done. So okay, and if you look at one of these rectangles, this is called the jth rectangle. This rectangle has been marked as the jth rectangle. One of these rectangles is called the jth rectangle. Okay, in this rectangle, let us assume that the value of the force is fj. Okay, and this is the average value of the force along this part of the curve. Now we can see that instead of D, we are going to use delta X. Instead of F, we are going to use Fj average for just this one rectangle, one part of the curve, not the whole curve. Okay. So for the jth part, for the jth rectangle, which is one part of the curve, we can use this formula and calculate the work done delta Wj, which will be equal to the force that we just said will be Fj average. Fj average multiplied by, instead of D, we will have delta X, because we assume that the distance covered, displacement covered in this case is delta X. So then the formula becomes delta Wj is equal to Fj average into delta X. Okay. Again, there was a cosine factor, but since we are assuming that the displacement is along the x-axis, what will be the value of the angle? If the displacement is along x-axis, the value of the angle will be, yes,
Ma'am, will it 0?
0. Yes, the value of the angle will be 0. So if it is 0, then you will have cosine of 0 is equal to, cosine of 0 is equal to
1. 1, ma'am.
1. Yes. So if it's 1, then you don't need to write cosine. And that's why we have this formula for the jth rectangle, delta Wj is equal to Fj average into delta X. Okay. So therefore, we can do this calculation for each of these rectangles where the value of f will be different. And we can find the work done in each of the rectangles, let's say W1, W2, W3, and so on up till the last rectangle. And then we can add all of these work done in order to find the total work done. So the formula we will use for each rectangle will be the same as equation 7.29 that we have just discussed. And therefore, this sign, capital sigma, you know, means, capital sigma means summation. So this is a summation sign, and this sign shows you that you are adding all the work done in each of these rectangles and then taking the sum, and you're getting the total work done, which is W. So this is the difference. So the last class was about the simple work done where the force was the same throughout the displacement, but now we are talking about a force that is changing as the position is changing, and therefore we have to modify the formula a little bit, and we have to calculate the work done by adding all the work done in each of these rectangles. So this is equation number 7.30. Now, in order to get the correct value of the work done, these rectangles have to be as small as possible. So which means that delta x has to be almost equal to 0, but not really equal to 0. So when something is almost equal to 0, but not equal to 0, we call it limit. Delta x tends to 0. This arrow is known as it tends to, it is approaching 0, but it is not exactly 0, because if it's 0, then your value will be 0. So this word is like it goes towards, it's approaching, it tends towards 0. Okay, so if you make very fine rectangles with very small values of delta x, you will see that the value for the work done becomes the sum of the work done in each of these individual intervals. And as you know that when we do a sum over very small values with a limit applied, this is called integration, right? And therefore, instead of writing limit and sigma, we can replace it by an integral sign. Okay, so we talked about an integral sign in the previous class as well. So the integral sign, you apply the limits, the initial displacement, the final value of the position, the variable force fx over the displacement dx. And this becomes the final formula for finding the work done by a variable.
Excuse me, ma'am.
Yes, beta. Who is this speaking, please?
मैम सोहेब ताहिर.
Soheb Tahir. Yes, Soheb.
मैम जो इवन वाले रोल नंबर्स हैं
हाँ जी
पिछली 2 क्लास से तो अभी तक मॉडल पे अपलोड ही नहीं हुई.
बेटा, आपका वो सोहेब बाद में आप आए हो क्लास में, मैंने शुरू में बता दिया था क्लास में, बल्कि मैंने पिछले हफ्ते भी बता दिया था कि आप YouTube को सब्सक्राइब करो, वो YouTube में है क्लासें. इज दैट क्लियर?
नहीं ये जो ओके ओके मैम ओके.
हाँ, वहां पे देखो, वहां पे है क्लासें. ठीक है, ओके. Now I'm going to take the attendance of the class. Okay, so let's see how many people we have with us right now, although I can also see it on Moodle directly. Okay, so don't try to put in any proxies. I can see all the students that are here, but I would like to also call out your names so that you also know. So let's see. Today is the 27th of November. Okay, so Muhammad Sarmad Salim is not here. Amar is not here. Amar bin Nasir. Abu Bakr. Abu Bakr.
Present, ma'am.
Yes.
Present,
Fatma.
ma'am.
Good. Fatma Babar. No. Muhammad Usman. No. And Anam Basharat. No. Bilal Muhammad. Muhammad Bilal.
Present, ma'am.
Yes. Beta.
Present, ma'am.
Yes. Hamza Dar. No. Fariduddin.
Yes, ma'am.
Yes. This is Kessler. Kessler is not with us. Zarish Harun. No.
Yes, ma'am.
Acha, good. So Haris, Muhammad Haris.
Yes, ma'am.
Okay. And Muaz.
Yes, ma'am.
Yes. आप Zoom पे जो अपना account बनाते हो ना, please make it with your proper name, okay? Otherwise, you will not be allowed in the class, okay? Hafiz Ibrahim. Hafiz Ibrahim is not with us, right? Huma Ishad. No. Alina. No. Muhammad Hunain. No. Rana Shehbaz.
Yes, ma'am.
Yes, beta. So Sania.
Present, ma'am.
Yes. Arisha. No. Okay. And Chand Khushi.
Yes, ma'am. Present.
Good. So Chand Khushi is there. Maiza.
Yes, ma'am.
Yes. And Yusuf Patras. No. Abira. No. Nadia. No. Hayan Ahmed. No. Cheryl.
Present, ma'am.
Yes. Muhammad Ashreb. No. Huda Zahur. No. Amelia. No.
Present, ma'am.
Amelia is here, right? Okay. Bisma. Bisma is not there. Sayyid Sadiqullah. He's not here. And Soheb. Soheb.
मैम present present.
यस बेटा पूरा नाम लिखो अपना जूम अकाउंट पे, ठीक है?
Okay मैम.
तलहा मोहम्मद. मोहम्मद तलहा. He is not there. Ali Zulkarnain.
Yes, ma'am.
Yes, good. Okay, so I have informed all of you that the classes will be on Zoom. They will be according to the timetable that we had during regular classes. Everyone is informed and they should be attending these classes. Okay. Please mute your mics. Don't disturb the class. Okay. Only switch your mic on when you have something to answer a question or something. Okay. But otherwise keep it muted. So I'm showing you the formula tables. I'm going to share these with you, and these are the tables and that I've uploaded also on Moodle. So you can see, can you see these tables? Table A is the basic SI
हाँ
quantities.
मैम, आप मेरी अटेंडेंस लगा सकते हैं, मेरा इंटरनेट डाउन हो गया था.
मैंने आपकी नहीं लगाई. दूसरा
आई टेक्स्ट यू. नहीं
नहीं,
मैम, मेरा इंटरनेट डाउन हो गया था, कॉल डिस्कनेक्ट हो गई थी.
मैं चेक करूंगी आपने पहले लॉग इन किया था कि नहीं किया था, फिर मैं आपकी लगाऊंगी.
जी जी
वरना
sure.
ठीक है.
जी जी मैम.
हाँ. So you can see these tables which are very useful for you when you're solving the problems and practicing. So this I've uploaded them. This is table A, which is of the SI units. Then you have the different quantities. You have some constant values that you might need from time to time. Then you have some other data that can be useful. Again, you don't need to look at everything. Only look at the relevant part that you need when you're working. Okay, when you're studying. So these are reference tables. You can see them. And also what I want to draw your attention to right now, for example, you remember that we used the quadratic formula in one of the problems we were discussing in the beginning of the course, right? So you can see this is where we studied this formula for. We've also been using the trigonometric ratios. So you can see that there's an explanation of these formulas with the diagram here. You can see all the ratios and you can see the Pythagoras theorem and the trigonometric identities that we've been using. Again, you don't have to worry about unnecessary formulas. These formulas are more than what we need. Just look at the ones that are relevant for you and you can use them when working. Also, you know that we talked about product of vectors. For the product of vectors, we also talked about the dot product of I, j, k. You can see the values here. Again, you should also understand it when we explained it when we were studying the chapter on vectors. Similarly, you can see the matrix form of solving the cross product. I used this in one of the examples I discussed in class. So this is where the formula came from. Okay. And then what I want to draw your attention to right now is this derivatives and integrals. Again, don't get confused. We are only using the simple first or two formulas or three formulas, four formulas, not more. Okay. So we did talk about dx over dt. So these are relevant to the derivatives. And today we are talking about the integral formula like we had for the variable force. And you can see that you should know, let's say, the first four formulas at this time. These are the ones we are using right now. Okay, now I come back to the book where we were studying. and I'll show you what we are doing, how we are using these formulas. And yeah, just a moment. Okay, so this one here. Okay, so now you see this integral formula. This was the reason that I was showing you the tables. Now, Appendix E contains a list of common integrals. This was what I was just sharing with you and I was showing you, and it has also been uploaded to Moodle. You can see it from there. Now, when we talked about f along the x-axis, but it's also possible to have f in not just one dimension, but in 3 dimensions. If it's in 3 dimensions, then just like a vector, you add the x component, the y component, and the z component. Similarly, the displacement can be represented in terms of a sum of the x, y, and z displacements. Then as we did in vector product, we know that if you have x and y components, then you can take their product and add them to get the total. And similarly, if this force is variable, if it's changing with time, then for each of them you will apply an integral between the initial and final positions. So you have an integral for the x component, you have an integral for the y component, and you have an integral for the z component. Also, you can see that the limits are changing. For the x component, the displacement position limits are from x initial to x final. For the y component, the displacement or position limits are from y initial to y final. Similarly, for the z component, you have the limits from z initial to z final. So this is in case you have to solve a problem related to a vector that has x, y, and z components. But the basic formulas will remain the same. Hamza Dar, why do you have 2 accounts? Hamza Dar, why do we have 2 accounts for Hamza Dar? This is not correct. Hamza Dar, please answer. Hamza Dar, I'm going to disconnect you if you don't answer, okay?
मैम मेरा एक अकाउंट बंद है और इस
एक अकाउंट से आप कनेक्ट करें, आप 2 अकाउंट से क्यों कनेक्ट कर रहे हैं?
एक से ही है मैम, एक से ही है, 2 से नहीं है.
अच्छा, अगर मुझे 2 नजर आए तो I disconnect you, okay? Right. So we also talked about a theorem last time, which is known as Taha Kashif कौन है? Who is Taha Kashif? Is he in the class? I don't know any Taha Kashif. देखो, we only allow students who are registered. We cannot allow anyone else. No, I don't know this boy and I'm not going to allow him to enter. So, Maroon. अजीब सा नाम रखा है इसने अपना. I don't have this name in my list. Message. Taha Kashif is not enrolled in the class. Use your official ID. Okay, right. So let's talk about the work kinetic energy theorem. You remember the work kinetic energy theorem we had last time? The work done is equal to the change in the kinetic energy, right? You remember from the last class?
Yes, ma'am.
Good.
Yes, ma'am.
Good, good, good. Okay, so now we're going to talk about the same work kinetic energy theorem, and in this case it's with the only difference is the force is variable, which means it's not a constant force, it's a changing force. It will be, again, you don't have to worry about you know how this goes, but the basic principle remains the same, which is the work done is, this is the equation, the work done is equal to the final kinetic energy minus the initial kinetic energy, which is equal to delta K. So W is equal to the final kinetic energy minus the initial kinetic energy. And we know that the formula for kinetic energy is half mv squared. So for the final kinetic energy, you will put the value of velocity, which is the final velocity. And for the initial kinetic energy, you will put the value of velocity, which is the initial velocity. Okay. So now these are some examples that are using the formulas that we just discussed. Let's talk about power. You're familiar with the concept of power, right? So what is power? Yeah, can anyone answer that?
The ability to do work.
The ability to do work is a definition. But how will you say in terms of mathematics? In terms of mathematics, power is the work done per unit time, right? So you
Yes,
divide
ma'am.
work, you divide the work done by the time interval in which it was done, and you get the value of the average power, which is P average. Okay. So again, this can be written in terms of the derivative in order to get the instantaneous power. Instantaneous power, average and instantaneous, the difference is the same, like we had average velocity and instantaneous velocity. So average means over a period of time, instantaneous means at one particular time. So and in this case, what is the unit of power? If the unit for work is what? The unit for work is?
Joule.
Joule per second for power.
Yeah, so the unit for work is the same as the unit for energy, which is joules, and the unit for time is second. So therefore, the unit for power is joules per second, which is also called watts.
What? Yes, ma'am.
And the symbol for watt is a capital W. This is after the scientist who worked on this, right? You're familiar with this. Whenever you go, there are different types of power, right? The kind of power we are talking about is mechanical work or mechanical power. But you also have electrical power. And you remember that whenever you go to the market to buy a bulb, for example, you tell them how much watts you need. So that's the power, electrical power that you need. But at the moment, we are not studying electricity. We are studying mechanics. And therefore, we are talking about the mechanical power. So you know that every device has its own wattage. Wattage is the power. Also, you know that there's another unit of power that is used, which is in everyday life, which is known as the horsepower. So the wattage or watt is based on the SI system of units. The horsepower is an older system of units that is based on the British engineering system, in which the unit for work was foot pounds, and divide that by second and you get a horsepower. You still know that in many everyday things, for the example engine power, we talk about horsepower, and the conversion is 1 horsepower is equal to 746 watts. Again, another unit that we use is the kilowatt. You know, the kilo means 1000. So if the power is very high, it goes above 1000, then we start using the unit of kilowatts. And if again it's much higher than that, then we can use megajoules, for example. So these are the different units that we work with when we're dealing with power. Again, we know that power, the equation for power can also be written as a product of force and velocity, because work is equal to force multiplied by displacement, and if you divide it by time, displacement divided by time is velocity, and therefore we can also say that instantaneous power is the dot product of force and velocity. So this is another formula for power that you can use if you need. Okay, now let us do a problem in order to understand the concepts that we were talking about. Okay, So for this problem, let us look at problem 7.11. We can see that we have a block, okay? This block is being pulled in one direction with a force F1. It is being pulled in another direction with a force F2, and it has a constant velocity V. Now you can see that the force F1 is along the x-axis, but on the opposite side, which means the negative x-axis, you can see that the force F2 is making an angle of 60 degrees with the x-axis. Again, you can see that in this problem, we are not going to talk about friction. So we are going to neglect friction. So this is a statement. So let's come to the statement like we always do. Let's first understand the statement. We just described the okay. We just described the diagram. Now let's look at the statement. So we have forces. These are constant forces. They're not variable forces. Okay. F1 and F2. They're acting on a box which is moving, which is sliding, right? The force F1 has a magnitude equal to 2 newtons. So F1 is equal to 2 newtons. F2 is making an angle 60 and its magnitude is 4 newtons. So F2 is equal to 4 newtons. The speed V of the blocks is 3 meter per second. So V is equal to 3 meter per second. Now, what do we have to find? These are the given data that we have. What we have to find is what is the power due to each force acting on the box at that instant. So we have to find the power for the force F1. We have to find the power for the force F2. And then we have to find the total power F net, a combination of these two forces. Okay. So how will we do this? Now we have this data, we have F1, we have F2, we have V, we have to find P1. So for finding P1, we have to use a formula just as we had P is equal to FV cos phi on the last page, right? So we have F, we have V, we have phi. So phi, F1 is making an angle of how much? F1 is making an angle of 180 degrees with the positive x direction. So in this case, phi is equal to 180 degrees. So therefore, you're going to say the magnitude of the force 2 newtons multiplied by the velocity, which is 3, multiplied by cos of 180. Cos of 180, as we discussed previously also, is equal to -1. So the value becomes negative and the units are watt. The negative value means that this energy is being transferred from the box. Okay. The negative result, the explanation is here. The negative result tells us that the force is transferring energy from the box. And for the second force F2, the angle is 60 degrees as we can see in the diagram. So we are going to use the equation F2V cos phi 2. So now we are putting the magnitude of F2, which was 4 newtons, the velocity, which is 3 newtons, the angle, which is 60 degrees. Now you can find the cosine of 60 degrees and you calculate it and you get a positive 6 watts as the answer. Now positive answer means that F2 is transferring energy to the box. So the difference is from the box and to the box. So you're either giving energy to the box or you're taking energy from the box. So when this is the case, the final net energy will be the sum of the two powers, powers will be the sum of the two powers, P1 and P2. And so this is -6 plus 6, which is equal to 0. So the net power is 0. So this tells us that they cancel each other, and that's why the speed of the box remains constant. If they don't cancel each other, then the speed will not remain constant, rather it will change. Is that clear?
Yes, ma'am.
Good. Now let's look at the next problem, okay? For the next problem, this is the problem about a funny car. A funny car means not a usual car that we drive, not the standard cars, but rather the kinds of cars that we use in sports and other kinds of activities, right? So these cars have a different shape than the usual cars that we have, okay? So we have a funny car that does not lose traction, means it does not, you know, when you're trying to, you know, there are a lot of stunts and sports and games that are done with cars in races and so on. So you have to maintain a grip on the road. You have to perform your uh, control your speed and angle and everything in such a way that you're able to maintain a grip on the road, which means there should be a certain friction available. Otherwise, the car will slide and crash. So this is traction. The time it takes to race from rest, so it starts from rest and covers a distance equal to capital D. And of course, this all activity depends upon the engine's power P. The power is very important for this. So let us assume the power is constant. Let us derive the power in terms of the distance that it covers, the D and the power P. Let's look at the relationship between power and distance for this car. Okay. Now, we know the equation that P is equal to dW over dt, where W was the work done and T was the time. We know this equation, and we know that there's a certain, we also know that the work done is related to the kinetic energy of the car. So the final kinetic energy minus the initial kinetic energy. So let's look at these. In this case, we have W is equal to, we can say that W is equal to delta K, or we can say that dW, we can say that dW is equal to dK. D is used to represent a change. So the change in work is equal to the change in kinetic energy. So you can see this here. dW is equal to dK. If dW is equal to dK, then we know that the power equation, instead of dW, we can write dK. So we can write this is equal to dK divided by dt. Okay, I'm just drawing lines to separate this. Okay, so P is equal to dK over dt, or we can say dK is equal to P multiplied by dt. Okay, so this is one equation. If we integrate this equation, we integrate it from the value when it was 0 to the value when it becomes k, because we said that the car started from rest. When the car starts from rest, it means that the initial velocity was 0. If the initial velocity was 0, we know that the kinetic energy, it depends upon the velocity. You know, half mv and squared. So therefore, we can say the initial limit will be 0 and the final limit is k. Similarly, the time on the left hand side, we have to take the limits of the kinetic energy. On the right hand side, we are integrating with respect to time, so we have to take the limits of time. So the initial time is taken as 0 and the final time is taken as t, because we have not been given the values, so we are only using the symbols. So when you integrate dk, it becomes k. When you integrate p, it becomes p multiplied by t. Now again, you can look at the formulas for integration. Let me share it again with you. So the formula that we are using in this case is, let's look at them. So again, we're looking at this formula. In this one, okay, we have this formula, okay. So we had dk, you integrate it and you get k. And then the second one was, we had simple formula like p integral p dt, okay. So if it's integral p dt, then we can use the formula where we get just t. Okay, so p, we can use this second formula, okay, au. So in this case, p is not you know, we have to integrate with respect to t, so we have to take p out and it's just dt. So if it's just dt, then we have p, and just like the first formula, if it's just dt, it becomes t. So you get k on the left hand side and you get t p t on the right hand side. So now we go back and we share this. And now you understand how you integrated this and you got this equation, k is equal to pt. Okay? And therefore, we can put, instead of k, we can put its value half mv squared. And if we put half mv squared, we get half mv squared is equal to pt. It means v squared is equal to 2pt divided by m, and then v will be equal to under root 2pt divided by m. So this is the equation that you get for the value of velocity. Okay,
Yes, ma'am.
good. So now this is one step we've done. We had to find the relationship between d and p. So we have found something with p. Now let's try to relate the distance with the speed. In order to understand that, we know from the second chapter that the velocity is equal to dx over dt. In that case, we can write dx is equal to v in multiply by dt, and you integrate it. X is the position, so the position is the distance, right? It changes from 0 to capital D. V is the velocity. The time for the velocity changes from 0 to t because it depends upon t. Okay, you integrate them, use the same formula that I showed you just now, and just the first two formulas, and you will get that x is equal to, you will get x, the interval is 0 to d, is equal to, in this case 2p over m raised to half is a constant, is equal to integral t raised to half. So this is equal to t raised to half plus 1 divided by half plus 1, just like the formula that we had in that table that I showed you just now. Okay, so if it was integral x raised to m is equal to x raised to m plus 1 divided by m plus 1. Using that formula, you get this equation. Okay, you can solve it again yourself and practice it and you will understand it. So finally, what do? We can separate t from here and put all the other terms on the right hand side, and we get a relationship between d and p. Is that clear? So this was what we had to do. We had to derive the time in terms of d and p. So here we have the value of time in terms of d and p. Okay, and then you can
Yes,
explain.
ma'am.
So this is a very interesting problem. Don't be scared of it. ठीक है, इसमें छोटे छोटे 2-3 formulas यूज हो रहे इंटीग्रेशन के, जो मैंने आपको उस टेबल में दिखा दिए. ठीक है ना? सो अगेन प्रैक्टिस इट योरसेल्फ. और हमेशा बुक में जो प्रॉब्लम किया होता है ना, उसमें पूरे स्टेप्स नहीं लिखे होते. आप खुद जब करते हो, आप पूरे स्टेप्स लिख के करो. डोंट ट्राई टू जंप ओवर द स्टेप्स. When you solve all the steps, then it becomes clearer and more understandable. Is that clear? ठीक है?
Yes, ma'am.
So अब मैं
Yes, ma'am.
I'm going to stop here. मैं आपकी अटेंडेंस एक दफा फिर ले लेती हूँ, and let's see कितने लोग हैं इस वक्त क्लास में. अब let's see कौन बीच में शामिल हुआ है और कौन बीच में ड्रॉप हुआ है. Let's look at them. Okay, so Sarmad was not here. He's still not here. Abu Bakar.
Present.
हाँ, देखा, अबू बकर है अभी तक. अच्छा, फातिमा बाबर was not here from the beginning. Muhammad Usman was not here. Anam was not here. Bilal Muhammad.
Yes, ma'am.
Good. Hamza Dar.
Yes, ma'am.
हमजा डार आप पहले क्यों नहीं थे?
मैम मेरा कनेक्ट नहीं था हो रहा है.
नहीं, ये तो बड़ा अच्छा है, आपको पता है आपकी क्लास होनी है ना. फरीदुद्दीन.
Yes, ma'am.
Good. Kessler. Kessler was not. Zaresh, no. Haris, no.
Yes, ma'am.
Present.
Kessler आ गई है?
Yes, Zarish, ma'am.
Zaresh, okay, fine.
Haris, ma'am.
Muhammad Haris.
Yes, ma'am.
Good. And Muaz. Muaz चला गया, देखा वो अटेंडेंस लगवाने आया था. You see? Ibrahim, Hafiz Ibrahim, Huma Irshad, Alina Khaled, Hunain, Muhammad Hunain, Rana Shehbaz.
Yes, ma'am.
Good. Sania Ahmed.
Present, ma'am.
Good. Arisha. No. Chand Khushi. No. Chand Khushi bhi attendance
Yes,
lagwa ke-
ma'am. Yes, ma'am. Jaan Kushi.
Good. Chand Khushi. Maiza Asif.
Yes, ma'am.
Good. Yusuf Patras.
Yes, ma'am.
Okay. Abira. Nadia. Hayan Ahmed. Cheryl.
Yes, ma'am.
Good. Ashreb. Muhammad Ashreb. Huda Zahur. Amelia Samuel.
Yes, ma'am.
Okay, Amelia, right? Bisma Shabir. Sadiqullah, Sayyid Sadiqullah. No. Soheb Tahir. सोहेब ताहिर भी अटेंडेंस लगवा के चला गया है ना. ओके. मोहम्मद तलहा, he never came. Zulkarnain Ali.
Yes, ma'am.
Yes. Okay, good. So I hope you are now comfortable with the experience of taking the classes on Zoom. So we're using Zoom, we're using Moodle. I'm sending you notifications on your official email, FC Formanite email, plus on WhatsApp. Okay. And also the last 2 classes are available on YouTube. You can subscribe and you can see them. Is that clear?
Yes, ma'am.
Yes,
So
ma'am.
please practice this and complete your homework and submit it. Homework 2 is open and available to you for submission. Okay. It's based on chapters 4, 5, and 6. Remember, I told you that we are counting the topics according to the course outline, but the topics are not always the chapters. One topic can be in more than one chapter. So please study accordingly. Okay.
Okay, ma'am.
Okay. Thank you. Bye.
Goodbye, ma'am.
Bye, beta.